property is talking about the elevation of boiling point, okay? So the moment you introduce a solvent into a non-volatile solute, okay, you are going to elevate the boiling points, okay? So if you add the solvent into the solute, the boiling point is going to elevate or increase. So this is giving us, mathematically, it is giving us T minus TB is equal to change in T, okay? Where T is equal to boiling point of solution, okay? And where TB is the boiling point of solvent, okay? So where this change in T is talking about the elevation of what? Boiling point. So this elevation of boiling point is directly proportional to the Raoults law. So we can say that change in T is directly proportional to change in what? P, okay? Or you can say that change in T is directly proportional to P minus what? PS, okay? So we can say that T minus TB is directly proportional to P minus what? PS. So whatever that happens to this one, as this one increases or decreases, this one also does the same thing. So they are what? They are directly what? Proportional. So the next one we're going to look at now is how can we also use, I want you to focus on how you can be able to calculate the molecular weight of either the solute or the solvent using these properties. That is the main area you have to focus on. So this calculation part is very, very important. So the same way we were able to relate lowering of vapor pressure to the Raoults law and getting the molecular mass from them, we can also relate this elevation of boiling point to the Raoults law and then generate the formula we can use to calculate the what? The molecular mass. So we are going to determine the molecular mass of the solute from the what? Boiling point, from the elevation of boiling point, okay? So how do we do that? Recall that this change in T, which is difference in the boiling point of the solvent and the solution, is equal to the Raoults, it is proportional to the Raoults law, okay? So I can say it's directly proportional to P minus PS, okay? Over P. It is directly proportional to the Raoults law. And recall that this change in T is directly proportional to whatever this thing you are seeing here is the same thing as what? W capital M all over capital W M. Remember this expression, right? From our previous video, we told you that this thing here is saying here, this thing here is equal to W capital M all over, you can say M capital W, okay? Remember this expression, remember this. So this is also equal to this. So I can just remove this and introduce this. So since we are looking at the boiling point, for the boiling point, we are going to assume that the molar mass of solvent is constant, okay? If the molar mass of the solvent is kept constant, which one represents the molar mass of the solvent? Capital N represents molar mass of the what? Solvent. So this molar mass will be kept constant. If it's constant, we remove it from this expression, it's 1. So it's out. So we have that change in T is directly proportional to W over capital W times small m. Okay? So remember that W is the mass of the solute. M is the molar mass of the what? Of the solute too. So remember, what does this thing look like? Remember, W is mass of solute. Okay? Small m stands for molar mass of solute. Okay? Small m stands for molar mass of what? Solute. Right? Yes. While capital W stands for mass of solvents. So what does this thing look like to you? Remember something. Remember from your molality, W over M represents molality. Is that not so? Sorry, represents mole. W over M represents mole, while this represents mass of the solvent. So from what you are seeing here, I can also say that change in T is directly proportional to 1 over W multiplied by M over multiplied by W over M. Okay? Where this represents mole, right? This represents mole, and this represents what? Mass of the solvent. Okay? So if we want to convert this into molality, I will simply do what? What will I do? I will multiply. If I multiply, okay, I don't need to multiply. So change in T is equal to, if I put an equal sign, I will remove this proportionality sign. Okay? And I will use a constant called K. And the constant is KB multiplied by 1 over W times W over M. So this constant KB is what we call the boiling point elevation constant. Okay? This is what we call the boiling point elevation constant, or you can call it the ebullioscopic constant. Okay? So this constant, every question, every solvent you are going to use has its own elevation constant. So they will give you the constant in your calculation, so you have to evaluate it. So this is the formula you can use to evaluate the molecular weight from here. But there's something I want to show you here. There's something I want to show you here. Now, if you look at this, W over this represents mole, while W represents mass of the what? Solvent. So what you are seeing here is also the same thing as saying that you can say that change in T is equal to KB times W over M times 1 over W divided by 1000. If I divide this thing by 1000, it means that I have converted this mass of the solvent to what? Kilogram. Okay? So this thing you are seeing here represents, from here to here, represents molality. Molality, because molality is what? Mole divided by what? Mass of the solvent in kilogram. So we can also say that change in T is equal to KB times molality. I want to just derive another formula for you. So look at this formula here. Very important. You can find the molality of a solution if you know the difference in the elevation of boiling point. Then the KB will be given to you in every question. Then the molality is what you are going to either be looking for or what you are going to need to solve something in the question. So look at this expression carefully. Let me summarize the class again. We are trying to get the formula to calculate, or the equation that will help us get the molecular mass of the solute from the what? Elevation of what? Boiling point. And we know that elevation of boiling point is directly proportional to the what? To the Raoults law. And this is also the Raoults law. This is what is in here. Take note, this W is mass of solutes, okay? Don't mistake it. Then capital M is molar mass of solvents, okay? Then small m is molar mass of solutes, okay? Then capital W is mass of solvents, okay? So I'm saying that for this solution, for Raoults law, which is an ideal solution, considering the boiling point, we assume that the molar mass of the what? Of the solvent is constant, okay? If the molar mass is constant, we take this as 1. Capital M becomes 1. So this times 1 is W. Capital W is still here. This is still here. Okay? Proportional to. So if we remove this sign, okay? If I remove this sign, now what you are seeing here, W over capital W times small n. I separated this equation to have 1 over W times W over n, which is the same thing as this thing you are seeing here. Okay? I separated it for a reason. So if I remove this thing, I'll put equal to KB. KB is the constant of proportionality we have here. Multiplying this and this, which represents this. This is another equation for you can use to solve problem, okay? To find either this, or this. Now, I now said also that if you divide this W by 1000, remember W is the mass of the solvent. If you divide it by 1000, automatically it means that everything here is equal to molality, because molality is mole divided by mass of the solvent in kilogram. Why are we dividing by 1000? We are dividing by 1000 because we are converting this mass to kilogram, and automatically what we have here is what? Molality. So we are going to use this equation to solve a problem so you understand it better.